Good morning, children. I hope that everyone is fine. I'm removing my mask so that it will be clear. But please maintain social distancing. Wear mask in public places. Sanitize your hand. That is very, very important for your safety. I want each of the children to be safe during this COVID-19. Okay, we will proceed with the next. That is, in the last class we learned about as we move from left to right, what happened to the metallic character. As we move from left to right, already learned one by one. Now we will learn about when we move from top to bottom. Top to bottom. What are the properties we have here? And it's very, very easy. Please listen carefully. You can replay back, and we will start with this. As one move from top to bottom. As one move from top to bottom in a period, what happened? That is in vertical. The first one we will study with again valence electron. I like it short VE. Valence electron. What will happen as we move from top to bottom? The number of valence electron remains same as one move from top to bottom. Valence electron. You already learned that this will have one valence electron. That means as we move down here, hydrogen, lithium, sodium, all this will remain same. It will not change as we move down. That means all this group will have the same one. When you move down, valence electron does not change. I hope that's clear. And second one, same thing. This group, they have two valence electrons. You already know. These two valence electron, as we move down, either it's beryllium, magnesium, or calcium, whatever it may be, it will have two valence electron. As we move down, that means it does not affect. Same case here, boron, aluminium, gallium. This group will have three valence electron. Either here the last one or the first one, they'll have three. And here 14 group, 14 carbon, silicon, germanium, all these will have. If we move down, so the valence electron will not change. I hope that's clear. Same case, nitrogen, valence electron is 2. And if we move down here, this will be also 2, this will be 2, this all will be 2. Here, oxygen, and the last one also will be here same. It will be same here. As we move down, it does not have any effect. As we move here, valence electron is 6. All these will have valence electron 6. When you move down, once again, let me sum up with this. As we move down, valence electron will remain same. It's not changing. I hope that's clear. Okay, so I'll complete. Okay, now valence electron will be finished here. The second one is that after valence electron, we have this valency. Valency. What happened to the valency as we move from top to bottom? As one move from top to bottom, the valency in the group remains same. Therefore, all the elements in the group have the same valency. Same with the valence electron. We already know valence electron means the electron in the outermost cell. Valence electron, don't confuse with this. Valence electron means number of electrons present in the outermost cell. Valency means which took part in the chemical reaction. In very simple, let me explain like this. Valence electron, same. Valency also same. Like what I explained here. Like with respect to hydrogen, valency. This will have 1, 2. This also will have 3. This also will have 3. Whether you move down or up, it remains same. And this will have valency 4. This also will have 4, 4, 4. When you move down, it remains same. And this will have 3. Here it will be like this 3. And this will be 2 again. All these will have 2 valency also. And here 1 again. With respect to hydrogen. With respect to oxygen, this all will have 7. Whether you move down, it does not change. I hope it's clear. With respect to this it will remain same. And we will move to the third one. The third one is the size of atom. Third one, here this will be same again. And third one, what will be the size of an atom? When one moves down. Comparing, one move down is comparing like hydrogen, lithium and sodium. The valence is same. And valence electron also same. When we move down, the size of atom increases. That means the size will increase. Compared to this lithium and sodium, sodium will be bigger, potassium will be bigger. Compared to this beryllium and magnesium and calcium, as we move down, the size is increasing. It becomes bigger and bigger. As we move down, size of an atom become bigger and bigger. We already explained this size of atom. That is in terms of radius. The radius become bigger and bigger means the size of atom become bigger and bigger when one moves down from the top to down. And next one, that means here increases. And number 4, what will be number 4? Yes, metallic character. While going down the group 1, 2 and 30, we will have 2 here. Here metallic character A, alright, because we have to divide into 2. Here I will divide into 2 sections from here. As we move down, what happened to the metallic character? Group 1, 2 and 13. The metallic character of the element is increasing here. This group, the metallic character is increasing here. Yeah, it will increase as we move down. Metallic character 1, group 1, group 2 and group 13 increases. Let me put it aside like this. As we move down, 1, 2, 3, these will increases. And B, yeah, we have 2. And B, as one move down from top to bottom, what happened to the B? While going down in the group from non-metal, that's 14, 15, 16 and 7. Electronegative character of non-metal decreases. Electronegative, this group 14, 15, 16 to 17, it decreases. Electronegative here, it decreases again. That is group 14 to 17, the electronegative decreases. This group from here to here, the electronegative is decreasing. I hope that it's clear. Then we'll proceed to the next one. Chemical reactivity number 5. Chemical reactivity. What happened to the chemical reactivity as one moves down here? As one moves down from top to bottom, group this first group again. The first group, that is group 1, group 2 and group 13. While going down the group 1, 2 and 13, the chemical activity of metal increases here. Chemical activity of metal is increasing. This group 1, 2, 3. When we move down, compared to this, let's take an example here, 13. Boron and aluminum, chemical activity is increasing. Aluminum have higher. Here, gallium have higher again. Compare like this. Same thing, gallium and magnesium and calcium. If we compare these 3, as we move down, it increases. And we'll study about this group 14 to 17. While going down the group of non-metal, the chemical activity decreases here again. From here, it decreases. Chemical activity compared to this fluorine and chlorine, it becomes less and less. Decreases here. Like same case of this carbon and silicon. If we compare, when we move down, when we compare, carbon have higher and here it is less and less. I hope that it's clear. And we will go to next, that is the gradation of physical property while moving from top to bottom. While going down in a group of metals, the physical properties such as melting, boiling point decreases. Here, this metal group, when it moves down, the physical properties such as boiling point and melting point, it decreases. That means beryllium and magnesium. If you compare this one, this will have beryllium will have higher, magnesium will have less, and calcium will have more or less like this. When we move down, then the boiling point, melting point, this physical property is decreasing. And we will here the second portion here from 14. While going down the group of non-metal, the physical properties such as melting and boiling point increase gradually. Here, just opposite. The physical property, melting point and boiling point, it increase. Here, it decrease, increase. Like that, when you compare, it's easy. Here, compared to this magnesium and calcium, it here gradually it decrease. That means magnesium have higher, calcium have lower. And these two, chlorine and fluorine, let's take an example. Here it have less, and chlorine will have higher, and bromine will have higher. I hope that this clear. If any confusion, please feel free to ask. Thank you. Bye bye. See you. Okay, sir.